seen the past couple videos about number 14 and number 15 on the practice test. So I will be finishing off with number 16. I will not be doing the bonus question. Feel free to practice on your own and look at that, but I think my time will be better spent on questions that will actually be on your exam. So we are given that we have a right triangle that has one side that's opposite from an angle that we know is 20 centimeters, okay? And this angle right here is supposed to be 30 degrees, but it can change plus or minus that depending by 1 degree, okay? And we're wanting to see, because of that information, because of that change, we're wanting to understand how H will be affected, okay? So typically when we're talking about these margins of error, right, then we're wanting to know max error, to look at all those numbers. What we need to do, right, is we're going to be using our differentials, okay? So the differentials, if you're unsure, is whenever I have, so let me, for example, I have dy over dx, okay? Each of the parts on the top and bottom here are what's called a differential, okay? It's like a little piece of that whole derivative, which basically says that I change this much in this direction, in the x maybe, and I change this much up and down in the y direction, but it's kind of giving it a larger scale, because doing delta y or delta x, that looks like this, or delta x, will give you something slightly smaller, and so we like to use this to estimate a little more. So what we need to do, right, is I want to see how my h is affected by that plus or minus 1 in my degree, okay? So what I need to study is the change in h related to the change in theta, change in my angle, right? Which will be dh over d theta. I need to get to this point somehow, okay? So I can look at that. And the way I'm going to do that, right, is I don't necessarily know what this side of the triangle is, but I think I can go ahead and formulate a pretty good equation that'll capture all these things, right? Because this is my angle right here, and this is the opposite side of that triangle, of this right triangle, of course, and this is the hypotenuse, right? What trig function relates the opposite side to the hypotenuse? Well, that's sine theta. So I'll write that up here for all of us. The sine of theta is equal to the opposite side, which is always 20, right? The question says that it's always 20 over the hypotenuse, which is h. Okay? Now, I'm interested in getting dh in terms of d theta. So what I'd like to do is I'm going to take this equation and I'm going to solve it for h. So I multiply h up to both sides. So I get h sine theta equals 20. And then from there, I divide sine theta to both sides. So I'm going to get that the sine of theta is equal to 20. Why did I do that? Sorry, I want to apologize for that. I probably won't re-record that. I meant to divide the sine over, right? I hope that was understood. So I'm going to divide the sine over because I want to get the h by itself. So I'm going to get divided by sine theta. So we get h equals 20 over sine theta, which, as we know, whenever we have something in the denominator, I can rewrite this as 20 times sine theta to the negative first power. Okay, now this is going to be helpful because I want to get the derivative of h with respect to theta, right? So I'm going to be taking the derivative of this right side. So what that means is when I take the derivative, right, so I'm going to write take the derivative, we're going to get that h, dh over d theta, is equal to negative 20 times sine theta to the negative second power. That's just by my general power rule. And then I take the derivative of sine and multiply it, right? Because of chain rule, which is going to be cosine of theta. Okay? I'm going to rewrite this real fast. So we're going to get dh over d theta equals negative 20 cosine theta over sine squared theta. Okay, so from here, right, what we're looking for, right, is the change in the hypotenuse, right? We know what the change in d theta is, which is this 1 degree, but I want to find the change in the hypotenuse. So I'm going to look for dh, and I'm going to multiply this d theta to both sides, because that's the error of the theta. I'm going to get dh is negative 20 times the cosine of theta over sine squared theta times d theta. Just like that. Okay. So that's a good start. Now we just have to worry about plugging things in. Okay, so if you'll permit me, I'm going to erase this so I have some more room to work with. Now, we can get sine theta and cosine theta from, and we're going to use 30 as our basic angle. So I'm calling theta 30 degrees and d theta is 1 degree. That's the change to the left or right. So sine of theta, if you remember this from trig, this is the same thing as 1/2, and the cosine of theta, this is the same thing as root 3 divided by 2, and that's when that's 30 degrees. Okay? Now the thing about d theta, right? Whenever I'm doing a lot of calculations like this, I need to do it in terms of radians. Okay? Especially if it's multiplying on the outside. This 30 degrees was okay because it was inside sine and cosine, and I know what to do. But since this d theta is outside the sine and cosine, I need to write this in radians. So to convert something to radians, right, I take that thing and I multiply it by pi over 180 degrees. And the reason for that is because 180 degrees, right, halfway around a circle, is equivalent or the same thing as going pi radians around the circle. Okay, so just halfway. So this is going to give me pi over 180 radians. Okay, so this is going to leave us with the fact that, and I'll bring this up, dh equals negative 20 times cosine theta, which is the square root of 3 over 2. So we see some simplifying, over 1/2 squared, because that's sine theta, and then multiplied by pi over 180. Okay, for the d theta. So we're going to see some things kind of work itself out. I invite you, and I'll kind of work it out a little bit, but please, try to do this math on your own. If I divide 20, this 20 and this 180 here will kind of simplify, divide into each other. So this 20 is going to leave me with 1, and this 180 is going to leave me with 9. Okay? And then from there, I'm going to be left with root 3 over 2, and that's a negative, right? Carrying across that negative 1 from here. And then this is going to be multiplied by 1/2 squared is 1/4, but I take that and flip it. So that's going to be the same thing as 4 over 1. And then I multiply that by pi over 9, which is from here. Okay? So, once again, this 4 and this 2 cancel each other out slightly. I can divide a 2 from both, so I get 2 here and 1 here. And this is going to leave me with a final answer for dh as negative root 3 times 2 over 9. This is times pi. Okay, now the key might have a slightly different answer than this. This is actually the same answer as the one in the key, but what happens in the key is that we take this 9, and I can think about it as, so I'm going to flip the 2 pi and the root 3 around real quick, so I get negative 2 pi root 3, and this is, 9 is the same thing as 3 times 3, right? And of course, anytime you have root 3, or sorry, anytime you have 3, right, you can think about that as root 3 squared. So once again, just let me reaffirm, this is correct, so you can leave that, but also I want to show where the key answer comes from. So this is still 9 on the bottom, but what we can see is 1 square root 3 divides out, and so we're left with negative 2 pi over 3 root 3, and this is centimeters. Actually, yeah, it's just going to be centimeters, right? Because that's height. So this is the error caused not in the height but in the hypotenuse as a result of that plus or minus 1 degrees from the angle. Okay, great. So this is part A of the question. Part B is very simple. I'm going to erase this. I assume you can always pause it and write things down as needed. I'll leave that part at the bottom. So this is part A. Part B is asking me to find the percentage error. And the way to find the percentage error is I take DH, so I'll write PE, percentage error, is equal to DH, which we just found, divided by H, right, with what H is supposed to be, right, which we can calculate, and then multiply that by 100, because that'll give us the actual percentage. Okay, so let's go through and calculate H real quick, right? So we know that, if you remember earlier, I think I erased it already, but I'll put it back. H is the same thing as 20 over sine of theta, right? And we discussed the sine of theta at 30 degrees, right, when theta is 30, is the same thing as 1/2. So we can simplify that, and we get 40, so that's 40 centimeters. Okay? Now, what we're left with after doing that is I'm going to get the percentage error is the same thing as this, the negative 2 pi over 3 root 3, and that's divided by 40, and that's times 100%. So feel free to simplify here as much as you want to. This doesn't give us a, it won't really give us a nice answer. The one provided in the key is just a decimal, so you could simplify this a little bit and call that good. Just make sure to multiply the 100. Maybe you can simplify things there, but this should end up being about, now what we're going to do is the negative here is important, but I'm going to take the absolute value of this, right? Because I don't really care which direction that's going. I just want to see how off I am, essentially. So that sign doesn't matter much to me. So when the minus goes away, I'm going to end up with approximately 3.02%. Okay? And so that is the percentage error. Okay? So that is how to do that problem. Hopefully you followed that all, and I thank you so much for watching.